Well, welcome everyone. It's been a pretty amazing day as far as listening to the various presentations. Today we're going to talk about what's happening around application transformation, leveraging technology like AI. So this represents pretty much what everyone has been facing around technology debt, security issues, right? All very familiar with your legacy estate of your applications. Now you compound this with changes around the workforce, right? Early retirement, these technology shifts, what's the operational model to be able to go support these applications, right? So now you have this legacy estate, which is really preventing some of the great things that were talked about today around AI and AI adoption, right? So we have to transform these applications in order to be able to go enable them to be able to then move forward. Or we're having to scrap them and basically start a new build. So what does that mean? Hey, we look to AI to solve everything, right? Not exactly the case. Doesn't work that way. I heard a laugh over there and a smile over here. Great. So, why is that? When we're looking at these legacy applications, and many of them could be millions and millions of lines of code, this becomes very difficult. You try to rely on these solutions that were out there and heavily marketed, and there's hallucinations and other things that can happen with these applications. And really, the key is understanding what they do. So that human level of intelligence is where we spend our time, right? And a lot of this very much upfront in how to get started.
If you take a step back and think about large language models, the middle word is language. So you think of software code, right, as languages, as technology languages. The biggest use cases right now in AI, when you're tracking really, that are seeing productivity benefits, business cases actually written around them, which is a real challenge with AI, is getting real corporate business cases around them, are really around software development and software modernization. Why? Because software languages are more structured. They lend themselves more easily to language models to provide some predictive analysis. Yet that doesn't really solve the complete problem when you start trying to understand legacy code to modernize it. And one reason for that is that language models are trained on repositories, open source repositories primarily. Their language models are scanning every open repository that's out there. These are units of code. These are files of code, often duplicated 30, 40, 50 times within a repository. Sometimes there's stubs, sometimes there's test scripts. There's a lot of stuff in repositories that don't necessarily reflect what you would see in a large enterprise or mission system that is deployed to run a business or to run government. So the language models are relying upon probabilistic analysis. Slide here. You have this clicker, or is that?
Let's see.
The language models are relying upon probabilistic analysis to try to understand, how code is organized to be able to provide the modernization algorithm to feed the agentic AI that didn't modernize the code. This is where the first step in modernization of legacy assets, understanding and having a clear understanding of what is in that legacy code, is an essential starting point for any modernization journey that would use AI. Why? Because the AI by itself isn't complete. AI will only go so far. So if you take the example on the left and you see these dependencies across these different beans, Java beans that are interacting with each other, AI will only carry that so far because it then loses the thread, the probability that there's additional dependencies. Why is that a problem? It's a problem because then the human in the loop has to go figure that out manually, right? So what if you can feed the AI with deterministic data that is much more accurate and much more complete? And that's what our firm CAST is supporting IBM with, the technology to help support this kind of modernization. So the view on the right shows data that describes the code as is with a complete dependency call across the different components of the software.
So how's that typically performed, right, to even get to that kind of a point? You pay for an assessment, we try to understand the application and then what to go do with it, right? That in itself takes a lot of time, resources, let alone, okay, now here's the plan, and then it's unfeasible. So then you just keep sustaining this application.
Right. So when you modernize existing systems, whether it's running an airplane, whether it's running tax, whether it's running a bank. It doesn't really matter. These are complex applications that have multiple layers. Any modification of any component within that system has to be reintegrated into the application. So where full stack analysis, which is what CAST does, is important is that it not only captures the code that would be sitting in a repository that you would see, but also captures all the different calls to databases, data feeds, batches, or to all the different interfaces, sensors, whatever you might have on a front end that's bringing data into that system. Because when you're modernizing or transforming legacy, you don't really modernize code, you have to modernize that business process flow that exists in the code. Those can be very, very large systems. Changing an application requires a lot of testing, there's a lot of risk in those systems. And that's one reason why having a clear window that you can then apply your modernization against is very important. AI today would require a language model for each different language that would make up that stack. It doesn't have the ability to reconcile the nature of those calls across the different technology stacks that make up a complex system. Luis?
Right, so understanding what you're going to change before you make a change, right? Clearly you want human in the loop as well, but still figuring this part of it out, right? The tool here allows us to go accelerate that effort.
Yep.
And then verifying what did we change, does it do what we need it to do, right? Being able to go commit to that going forward as well.
Yep. So the nice pictures we just showed were to clarify the concept, but this is really what an app looks like. So when you're trying to make a change, a simple change, we are going to take a legacy on-premise system that's been running in a data center for 25, 30 years, and we're going to move it to AWS. Okay? That sounds easy. There may be some AI to help a little bit if it's a very small, simple app. But what you're seeing here in each of these blue highlights are identifying code within call paths that have very specific blockers to move that application and take advantage of native cloud. This is exacerbated when you start expanding systems and we start thinking in terms of portfolios. This is where the power of AI, properly managed, properly fed with deterministic data, can then lead you to accelerate outcomes.
Yeah, I really like this around de-risking migrations. So many times when we approach migrations, we provide an estimate, we provide a range, you run into these type of blockers, expectations change, budgets maybe need to be increased and so on, right? Or then delays, especially if you're trying to exit a data center or maybe you're trying to make a technology shift from a virtualization platform to something else, and now you've hit a window where you have to either revert back or you have to just kind of continue as is until the next cycle.
Yep. So the first step in the journey in a modernization initiative, whether you're using AI or humans, or using both most likely, is having that baseline for software intelligence. But now the next step is once you have that baseline, what do you do with it, Luis?
Right, so from here, this is, I'll get into the approach here next, but this is something where it's continuous, and this ability to go accelerate it really is the key. You don't just build once and have to always build again every single time you touch the application. You need to learn, have this platform basically learn in order to keep improving upon this. So those are the kind of experiences that we've recognized as we've been doing this for now a number of years as far as our experimentation with AI, our creation, and now these type of capabilities. So when we looked at the type of tools and type of capabilities that were offered to us, right, in industry, this is kind of the same way we all do this. Some level of getting to deterministic data, applying, creating these agents, and then calling on these LLMs. As you can see in the middle, general purpose LLMs can create issues. More issues than maybe what you already had, and then you have to go remediate and go fix that. Also, this can become very costly, right? Many of our clients are already facing issues around token overrun, out of control, right? The adoption of AI, I see a yes, right? The adoption of AI creates that other type of challenge, and then also the financial insights that are necessary there as well. So as we look at this and we decided, as we experienced kind of what was out there and as we further developed what we have, we found a better way, right? And that means we need to understand the portfolio of the application, not just say from vulnerabilities, but what's the intent of the app? How do we make these best decisions? Thus, in this partnership with CAST. And then as we understand the application, we can better identify, okay, this is the type of work that needs to be performed. Thus, we'll go create an agent to do a specific type of task. And then from there, as we prefer not to call on the LLMs because, again, of the fact around the cost. So we have, at global scale, many applications that we've modernized, that we've created these recipes for these different code types, and we look to call to those first. Don't necessarily answer it 100% of the way. Then we start looking at LLMs. And then we look at multiple LLMs till we can get it to basically a satisfaction level that we like the changes. And those are the agents. So we always have human in the loop. We always have checkpoints to make sure that as we go through every step, we make sure everything's working in the way that we expected. So as you can see, right, we start with what we've been talking about around CAST to really understand the application and understanding all of those elements you see there in the box, feeding into the next agent that then will take a look at that and help us understand what we should expect, right? And then as we move forward, we go look at the recipes that are already existing and look to call on those to go apply these changes. And as that may not always be a fit, or may not hit 100% of what the outcome is we're trying to achieve, we keep moving down the line. And we keep testing it, we keep validating it until we get the answer that we're looking for as far as the level of quality that we're looking to go achieve. And then we call it a success, and then it ships it off on its way to the repo to where we can now put it into a container. And as you can see, really to any type of a container platform that you may choose. That's how we de-risk a migration, not just from a virtual machine to another, not just from, say, Java 8 to all the way to Java 21. But this is the approach that we take, and those are the kind of results that we have been seeing.
So let's talk a minute about the outcomes. So Luis mentioned to a quality state that is acceptable. You may not be aware, but until 2021, there was not actually a standard for good software. There were a lot of rules. This is good Java. This is good .NET code. This is good C++. But until 2021, ISO did not have a standard for what would be good software that's automatable that could be put into an automated process. IBM and CAST, since its inception, have been supporting ISO standards in regards to automated measures that can then be applied not just against human code or human-delivered code, but importantly, to validate the AI-generated code that's being designed in accordance with security and maintainability and changeability factors that are essential over time. So by being able to continue through an automated process to get to a level of quality that was already challenging to get with human developers, right, Luis?
That's right.
We can also talk about how we do that at lower cost and higher efficiency.
So as we look at the application, right, typically in our pipelines we manage, we're looking for vulnerabilities and putting those out as soon as we can. With this ISO standard is built around the quality of the app, right? Is this of quality? Is this of where the level is that we're also getting the performance and everything else that we expect of this application? Is it a healthy application? So this is an example from a real app that we have that it's basically been into sustain mode, right? Vulnerabilities are pretty checked, but as we looked at the scans, we're like, well, this does represent the tech debt, right? This is kind of what we were facing. So the estimate that you see there in the before picture, the before column, the number of days that it would take to actually get to the quality level that's expected, and then also go resolve the technical debt. And then as you can see on the right, the results were pretty low, right? That's creating about a cost savings of avoided cost to go resolve the tech debt of about $500,000. More importantly, the amount of work that's left over now for the humans to go do is about a month, right? Versus almost untenable, right? You wouldn't even attempt this type of an effort considering how long it may take, how many resources you may need to throw at it. By the way, that 32 days is actually, we've already improved upon that from what we just did this week. So that's actually a little bit dated now. But what happens there is that we're greatly reducing the amount of human effort that's then necessary, right? We're also identifying, well, what exactly does remain that has to be fixed. So if you think about doing more with less, now we're able to enable our SMEs to now go focus on the areas that remains in order to go improve, continue to improve this application. So if you think about this from the life cycle of the app, and this is what we're seeing, right? Traditional methods of how integrators like ourselves would approach this versus this assisted model with these agents. Seeing these type of gains all along, right? And also on the ongoing side, you could see how significant of a difference this is. That means to ensure this quality remains. This is another example we have of an application, 3.5 million lines of code. To go figure out what we need to do with it took us about 6 hours using Cast. And then from there, the continued work that we would go do, upgrading it to the current version of Java, and then also knocking out critical violations. So now let's think about this with the budgets you have. Many of our clients have persistent budgets and even a lot of unknowns in what they're going to be able to spend to go modernize. Well, we also see this as an opportunity where if we can start tackling the tech debt, we can create this cascading effect where you can reinvest and create a self-funded modernization model. You do the first app, the next one, and so on. You get this snowball effect. And we see overall, kind of a classic 80-20 rule, but you're spending most of your budget on keeping the lights on. Yep. And then about 30% or so, 20 to 40% is actually the range of typically what the technical debt is of your operational budget. So there's a lot of opportunity there to go unlock that. To go further, on the middle there, that bottom piece around the O&M. Not talking about this capability today, but now if you start applying not just to modernizing the app, but what the ongoing piece would be. Our approach to how we would do DevSecOps, we have a platform, product design engineering factory, that we've built a lot of automation and a lot of various agents in. That's also allowing us to do this with about half the people that it normally would take, with these type of results as well. As you can see, this is pretty key to ensuring the quality of the application ongoing and being able to also make sure that now your applications are in a future state. Now you can actually go do something with it. So the kind of results we see are clients are now able to go reimagine the applications where they weren't able to before. This came out a couple months back from Everest Group. This is the Peak Matrix. As you can see, IBM's on the top right. We've been at this for a while, right? We have a lot of lessons learned that we've reinvested into these various accelerators and various methods that we take. So while we're talking about app modernization, this is also about getting the apps, again, to the state where you can go reimagine them. The other things that we're able to provide around it, right, around AI enabling them or quickly deploying the applications, right? This is part of the breadth of the portfolio that we can also bring to the picture. So along that type of a journey, this is how we usually see the evolution, as you could say, around the application. We've spent most of our time today talking about these kind of first three areas. So that's around our suite of capabilities called IBM Consulting Advantage for Cloud Transformation. That allows us to get on this journey with this legacy estate of applications. And then what we also notice is that, well, we've made a flip, right? Let's say you're heavily virtualized today on virtual machines, and now we're going to go to containers on our friends from Red Hat. And you basically now expose a hole there that you didn't realize before, which is your operational model, right? Cultural change and all these other things also have to happen, but your operating model can't sustain these modern apps. I've just made an acceleration to now a modern estate. Well, this is where, again, the product design engineering factory helps us manage this, helps us put more people into value rather than just in the operations side. In government, we have to get these applications to be approved to operate in the environment. We can also automate a lot of this process as well to accelerate that. And then underlying the operations and self-healing type infrastructures is where we go with AI ops, and then the visibility around FinOps and further reducing those costs. So now that we've created all this room for efficiencies, what do we do next? We look to go empower the workforce. So the set of capabilities around developer advantage means we will put these type of tools in the hands of your developer community so that now they can go spend the time on the mission value, right? Versus just operating and dealing with legacy estates. So you flip it from paying for sustainment to now paying for innovation, right? And enabling your workforce for the innovation. And the last piece there, ICA for agentic applications. Now let's talk about AI enablement. Quickly being able to create prototypes, quickly being able to create MVPs, and then bringing those out into market or getting those into the mission. So this is the last slide. I'll tell you a story of a government agency that we had worked with. So we were there for a while, and this was a code base. This was a mainframe application back in, I think, built around, well, typically code base for this one was like a 1960s, 70s type of code base. This is assembly code in this case. I never learned about it till I was at IBM, by the way, so I didn't know that existed. So as you can see, 90% of the developer workforce took early retirement, right? A major disruption to this client. And they had an integrator working in this environment, modernizing a system of about 500,000 lines of code for the last 18 months, and not really being able to get much of a working solution. So with the impact, with a lot of pressures on them, they came to us and said, hey, we heard about what you're doing with this other system, which is a similar code type. Could you come in and take a look at this and see what you can do? Sure. But you have 2 weeks to do it, and here's 19,000 lines of code that you've never seen before, okay? Well, because we had the solution, we were able to quickly produce those results. So some of those metrics that you saw earlier, some of this is being done in a matter of hours, right? We have 1 day on there. But that also means we didn't need to disrupt our client. We only needed about a couple hours of their time to help us understand what we had to go do. And then as you can see, in about 9 days, we delivered 2 working solutions, and then fully briefed the client, answered every question that they had, and now our team is doing this work. You're more than welcome to take a picture or scan the QR code if you'd like to see a demo, but I'll challenge that. This always is best if you can provide a sample of your code, right? It doesn't have to be the whole thing, but we're definitely encouraging our clients to put more sample code as they issue RFIs, and asking industry to see what they can do with this. Oh, one last thing. There's a white paper that we had recently published through CIO.com. Pretty good read, 16 pages. You're welcome to download it. And this is IBM with AWS around how we approach this space around agentic AI app mod. So I think we'll take some questions.
Sounds good. What kind of questions? Great, thank you.
So I'll ask a question to start. So when you're working with customers, some of the, at least federal government customers, have a budget challenge that they spend so much on legacy systems and legacy system maintenance. Is how do you present either your approach or an alternative approach to enable them to move to newer systems and not be locked in like they are?
Right, right. No, I think that was a big part of the illustration, Luis, that you showed, right? Being able to take the OpEx from sustainment and sort of reallocating it as you're delivering modernization. I thought you did a good job.
To be honest, sometimes nowadays it's kind of what hurts the most gets the priority. And that's what we're being asked to go in and can you help me? Can you look at this? What are you able to go do, right? And that does mean that ultimately, while that might be a particular effort and that might be funded, the real key here is going to be the applicability of what else could you do. Once you identify an answer for a particular code type, can you do the next one just like it? Like in this previous example of the assembly code, right? The original system was in the 1960s. The next one, we were able to do this in 9 days because we were able to reapply the same solution. That's the velocity or behind that self-funded modernization that will unlock those funds from the budget. One more thing too, around the budget constraints, if I just said a few times about how quickly we can deliver this, what that allows us to go do is instead of you, the client, paying for T&M, for teams to come in and getting mixed results and struggling or whatever else challenges may come the way, I can offer to you instead, well, how about I take a bet and I'll do this in firm fixed price and I'll tell you what kind of outcomes, because of the sample code you gave me, that I think we can go achieve, which is a far more favorable contract mechanism for you. And around us allows us to make a bet.
I think and a big key there, the foot stomp, right, is the deterministic baseline analysis, knowing what you have when you start. A lot of modernization projects learn a lot during the project, which requires rework. Rework is waste. Rework is expensive. What you're hearing here is, let's take a deterministic baseline, let's power AI. This is where AI is very, very useful, and the agentic approach, and then automate that, and you get the outcomes much, much more quickly.
Yeah, on that point, right? That's measuring twice, cutting once.
Yeah.
That's ultimately how we approach this.
I'll ask one more question related to Jamie's talk this morning. So there's a number of examples of smaller agencies that have had very large success at modernization. FCC a number of years ago, they really flipped it from the maintenance to innovation and new systems. But the really large agencies, as Jamie mentioned, there's quite a bit of culture, and there's a current staff with their expertise. Mm-hmm. So how do you recommend someone to engage in that aspect of it as well as the modernization? And for a very large agency, how do you and the customer client decide where to actually start?
Mm-hmm. The reality there is, as the larger the systems, the larger single kind of purpose program for that system. So that's usually how we would start, right? The one example we have that's pretty popular, especially we presented a couple years ago in AWS Gov Summit around the IRS. We were transforming basically the system that manages all of our tax returns. So large system, large project that we undertook, and part of that cultural change though was also working side by side, right, in a very co-working type of model. And what we found and then was to be able to go work with the developer teams, not just to make their life easier, but ultimately get them to start rethinking of how would this application then best behave now that it's in a modern state on modern infrastructure where it never was or never intended to be before. That's the value that we ultimately unlocked there that I think was really to that kind of an ROI story.
Yeah, and maybe there's one other answer as well there, and of course IBM supports all these different paths, but we see with smaller agencies like FCC, and we see a lot with state-level agencies, smaller state agencies, getting them out of the development business entirely, right? Replacing these environments with low-code, no-code environments or COTS packages that can handle some of these simple processes. A lot of the large agencies, DoD bespoke mission systems, et cetera, they don't have that option, right? They're going to be staying in custom systems because their mission and what they're doing is extremely customized. Case management systems, there's a lot of options. It's a lot of stuff, right? So I think however, we see a lot of customers using deterministic analysis to understand and find the business rules, the flows, whatever you have in your systems to make sure you can map those in designs, right? If you're going to move to a COTS package like a Salesforce or what have you, you still need to know, you still need to harvest what you have to make sure that if there's anything that's unique in that business flow, that you can capture that in whatever target platform you're moving to. And sometimes folks don't make that assessment early enough and end up, again, with a lot of rework late in the project that forces you to adapt and incur a lot of cost.
Thank you. Jamie, do you have a comment on legacy systems and O&M budgets and investing in new from your expertise?
Oh, he's smiling. He's
yeah, there's so many things to talk about. The first thing I'd like to say is if you have not caught Sam Corcus's YouTube interview, you need to watch at least the 30 minutes of that 2.5-hour interview. Sam Corcus was the acting CIO for the IRS over the last 10 months. He took some draconian methods, and it was not well received. However, what he says in that first 30 minutes is key to understanding the federal government and how IT staffs have formed over the last 30 and 40 years. So when you talk about IBM getting in there and changing a system and everything else, that's one of thousands, literally thousands of systems. Okay, so who cares? What's really going to change? And that's, I think, what Sam tried to do. He came in and tried to say, wait a second, this whole place needs to be shaken up because every year since 1995, they were always 5 years away from completing their project. Always 5 years. It's only 5 years away. And yet it's never been done. And why primarily is that done? In my assessment is the fact that there were the 5 big system integrators in there fighting amongst one another. And everyone was sabotaging the other in actually delivering things for the taxpayer. Besides that, Congress
We've
can
seen
get
it.
really crazy about what they want. They write laws that are contradictory in nature. And so you're left with things like the Anti-Deficiency Act. What? That means the Anti-Deficiency Act forms the fact that a government entity cannot create any more than 1 year of budget obligations. So, well, then how do you sign up for these multi-year programs and so forth? You have to get a secondary third party to accept the liability and the risk in that. All right, that's just the cost of doing business. But that cost of doing business is usually 30 to 35% more than you have to do. And so it's really crazy, the actual environment that you operate in. So all these things are technical, but really it's the culture and it's the systems that you operate within in order to make things really shake up. So yes, these technical things are the promise of the future. I love the deterministic versus the end, because if you do take, by the way, getting a little techie and geek, if you do take some of the small language models and then separate it and then put it in a defined space, oh my God, the things that you can produce are phenomenal. Yeah. But at the same time, you have to have the right mission. So doing a onesie, getting momentum is very key. Absolutely. Your question was, do I have an opinion about legacy systems and how to change? Yes. You have to show promise, you have to show success, and you gain small momentum, and then you build that momentum. But realize you are going to experience failures. So it's not so much that you fail, it's what you do with that failure and how you make it a success, because you're developing the experience. You fail small and you fail fast, and then you move on. You create just this whole momentum with people saying, yes, this is the way to go. And that's how you succeed.
Yeah, and foot stomping that, Jamie, when you were at PTO and shifting the environment into a product-based IT organization as opposed to just a Exhibit 300 type portfolio, which is all budget, but motivating the teams to start delivering these products. And I mean, we've worked with your teams over there. In fact, a cloud example similar to what we showed here was used at PTO. Being able to provide that information back so that folks could lead out. And I lived that environment that you described in your organization, where this notion of getting a product team to start, to show, to be trailblazers, to encourage trailblazers. And you know what? Trailblazers might pick the wrong trail or maybe the wrong path, but support them through that iteration. And I think you call them templates or stories, right? Yeah. That you can then repeat, and industrialize at scale. I think one thing that, Luis, I just want to kind of come back to it, because we work with IBM a lot in commercial sector globally. And no one writes contracts outside of the federal government the way the federal government writes contracts, right? I mean, fixed cost is already a thing of the past. It's all outcome-based contracts now, right? I mean, most federal contracts are time material. So there's a motivation to take your time. Sorry, but you probably lived that on the receiving end. What we are talking about here today is leveraging AI in a very practical way to take systems and transform them. And the kind of model that you're proposing is, let's try it out on something so you have evidence in your organization, then see if it can scale, start to roll it out. All paid for without really raising your budgets to accommodate the modernization piece. Yeah, I think the constraints we've seen or challenges that are creating some of that, it's also allowing the room for innovation, right? You have to think differently. Last thing I'll leave, spoke to a client just last year, and they told us, if we don't do the type of things you're doing, that we're seeing from you, if we don't take those approaches, we'll never get to our destination, right? And I think even more so now this year, this is where this type of creativity you need to experiment with. Thank you.
Thank you for joining, and thank you for your talk and partnering on the conference. Marc.
Sure. Maybe one last thought. There's a lot of academia and research folks. When I described the ISO 5055 standards that we supported, that our software supports, we did that in conjunction with MIT and MITRE and SCI and Carnegie Mellon. If your organizations are doing research around software modernization, AI modernization, topics along that line, we at CAST are very interested in supporting you with our technology so that we can educate and learn more about the marketplace. So thank you.
Thank you both.